Okay, let us continue the second part of today's class. Okay, has a property that the expectation, okay, here, expectation of S is equal to 0. Where S is the transmitted symbol. For example, in binary, for example, in binary phase shift keying, BPSK, if PR S is equal to +1, positive 1 is equal to the probability S is equal to -1 is equal to 1 second. Okay, this is equation 10. Okay, probability. And this is also the probability. Okay. Then the expectation of S is equal to positive 1 times (1/2) plus -1 times 1/2. Okay, which is equal to 1/2 minus 1/2, which is equal to 0. Okay, this is equation 11. Okay, like this. Similarly, you can check that the expectation of S is equal to 0 for quadrature phase shift. Phase shift key. Nothing. Phase shift key. Okay, QPSK 16 quadrature amplitude modulation QAM 64 QAM and 256 QAM. Then Okay, the expectation of S times S transpose is equal to the expectation of S minus 0 transpose. Okay, like this. And 0 is also a vector. Okay. And this is equal to the expectation of the of S minus minus the expectation of S and times S minus the expectation of S transpose. Oh, no, so I need to add this. Okay, and this. Okay, and this is equal to R SS. Okay, like this. And let me align at the equality sign. Okay, good. So this is equation 12. Okay, where 0 is equal to 0 vector is equal to 0 dots 0 transpose. Which is an NT time by 1 0 vector. Okay. Substituting equation substituting equation 12 into equation 9, we have we have this term is equal to H times the expectation of S times S transpose times H transpose is equal to H times RSS times H transpose. Next, we want to prove that this term the first term in equation 2 is equal to 0. So let us see the expectation of H times S times Z transpose, which is equal to the expectation of H. Then we search for H. H is equal to this. H S is equal to this matrix and this vector. And times the Z transpose. Let us search for vector Z. We do not have vector Z. So let us input Z1 dots Z n r. Like this. Next, let us multiply H and S together, and we will have this equation. The expectation of first, the H is an NR by NT matrix, and S is an NT by 1 matrix. So after the multiplication, it should be an NR by 1 vector. So let's use the bracket. NR by 1. So the first term is equal to let us see H11 to H1NT times S1 to SNT. So the first term is equal to I is equal to 1 to NT, and H1I times SI. Like this. This should be italic. And the vertical dots. And for the last term, it should be HRNR1 to HNRNT times H1 to SNT. So this should be summation. I is equal to 1 to NT. NT. And the first term is H N R I, and the second term is SI. Like this. So I should be italic. And the second vector is equal to Z1 to ZNR. Okay, and again, we can multiply these two vectors together. So it is equal to the expectation of, okay, summation I is equal to 1 to nt h1i si to summation I is equal to 1 to nt hnri si times z1 to znr. Okay, this is equal to the, okay, j is equal to 1 to nr, and summation, okay, I can copy this here. Summation I is equal to 1 to nt hji, okay, here becomes the j, okay, hji si and times zj, okay, like this. Okay, summation j, okay, j should be italic. J is equal to 1 to nr, and the summation I is equal to 1 to nt hi j italic hji times si times zj. Okay, and finally we can move the expectation into the double summation. Okay, like this. Okay, because hj's are constants, so the expectation is taken on the term si times zj. Okay, the expectation here of the si times zj, okay, here, okay, and let me align at the equality sign and add a white equality sign here. Okay, so we call this the equation 14. Okay, good. So next, in digital communications, it is reasonable to assume that transmitted symbols and noise terms are independent. Okay, therefore, okay, equation 14 is equal to equal to this. But now I can split this expectation into two terms. Okay, first is the expectation of si, and then times the expectation of zj, okay, like this, which is equal to 0. Okay, like this. Okay, why this is equal to 0? Where the last equality holds. results from the fact that noise terms, Zj, where J is equal to 1 to NR. Where J is equal to 1 to NR. R 0 mean. Because noise is always 0 mean. Therefore, this term, expectation of H times S times Z transpose is equal to 0. This is equation 16. Similarly, we can prove that the third term in equation 2 the third term in equation 2 the expectation of Z times S transpose times H transpose is equal to 0. This is equation 17. Next, we consider the the last term in equation 2. Expectation, or I can directly copy from equation 2. Expectation of Z times Z transpose is equal to the expectation of big brackets and the parentheses Z minus 0 and times Z minus 0 transpose like this and Z should be boldface, and I need a longer minus sign. Here. Here longer minus sign. Which is equal to the expectation of the big brackets of parentheses Z minus the expectation of Z because Z is 0 mean and times Z minus the expectation of Z transpose transpose like this. So let me change this to the boldface. So this one should be boldface and boldface and boldface. It is 25 minutes. Let us take a break.